In this video, we're going to talk about the Unity Engine API, some of the specifics about what makes Unity different from just regular C#, and also a bit about how the major structures of GameObject and component work together in your projects. So we'll start by opening up Unity. And we've already downloaded the demo project, which is used for all of our videos, and we've opened it up here in the project window, Assets, Unity with Cocktails, Lesson 2.3, which is about Unity Engine 1. Then we'll open up the one scene there, Lesson 2.3, and we'll give it a play. Okay. So we see in the console there's some things tracing out, and we'll take a look at what those are. I'm going to hit pause, or stop rather, but it will continue to show things there for a while. So let's take a look at the main class, Unity Engine 2.3. Double-clicking that will open up MonoDevelop. In this video, we assume you already know about the general OOP structure that's available in C#, and we've already seen how classes extend other classes. In this case, our Lesson 23, Unity Engine 1, is extending MonoBehavior. And you're going to do that for any of your classes that you want to add to GameObjects in the scene. So each of these projects in the hierarchy has a manager's GameObject, and that's an empty object that is sitting in the scene, but we don't take advantage of the graphics. We simply drag on the script specific to the lesson. You can see in the inspector window on the right that script is dragged in there in the component section under the transform. So let's talk a little bit about GameObjects and the component scripts that go onto them. So I'm going to jump over to web browser, and on the /Unity folder within my site, there's the home page for all of our Unity work, and there's a link for a core Unity 3D intro. We jump into that, and it goes over a lot of why you would use Unity, how it compares to some of the other platforms, and then gets into the specifics. It's recommended at this point in the video series that you just pause here, go ahead and read the complete article, because it's going to fill in some of the gaps from what we've covered already in the series and prepare us for going forward. A couple of the things that I want to call out here, and bump up the size of the font. So we have two core objects that we're going to talk about. One is the game object. So that is the entity that sits in our 3D world. It may or may not have graphics, but typically it does. Some examples of a game object are a cube, a sphere, a plane, all of which we can automatically create. Also, an imported 3D model would be a game object. Everything visual in the world, in the 3D space, is a game object. And then onto that game object, when we want to put some code, we put that into a component. And component is created from MonoBehavior. So the links here, you can jump right into the Unity documentation for both GameObject and MonoBehavior, which I have open. So MonoBehavior, it has a lot of functionality built in. You can get collision information when objects collide. You can get mouse information. You can get input from other controllers, from the accelerometer on mobile devices. A lot of that is built into MonoBehavior. It's probably our most important class. There's also some references to some of the expected components that you typically have on there. So for instance, rigid body is a property you can access, and that accesses the rigid body component on that game object. It may not be attached. It depends on the specifics of your project, but these are shortcuts to what is called the get component method that I'll show you during this video. There's also some ways to communicate and with broadcast message. We'll talk about that in this video as well. And you can talk about the life cycle when this object wakes up, when it starts, when it updates, when it gets destroyed, all of that stuff is in there. So that is mono behavior, very important. Good idea to take a look through that script as well at this point. And then GameObject itself. So an overly simplified way to look at it is GameObject is the visual thing, and each ability that it has is encapsulated in a component that sits on it. So its visuals are one component, taking input could be a different component, checking collision with other objects could be another component. You can really break each component out. Theoretically, one component could do everything you need, but it's better to break it down for a variety of reasons, including maintainability, extensibility of your project, having each component focus on just one thing, and components can freely communicate with each other to multiply their efficacy. And we'll look at that in this video too. So let's pop back to the script one more second. So we can see that even an empty game object here in the scene view is has at least one component, and that component is the transform, which sits on the inspector. So that is a required component that is in there by default, and that gives it an X, Y, and Z position, rotation, and scale within the scene. So the handles that you see here in the scene view, they're showing the orientation of what is currently an empty object, but we could make that visual as well by adding components such as a square mesh, a cube mesh or a sphere. So an example here might be within your 3D world, the game scene, you'd have one game object, let's say that's your enemy, and then each of these white boxes surrounding it would be different components. So we can see the mesh renderer linking to a material is what gives it a visual look, collider, audio, rigid body, particle system, script. You can add lots of stuff onto that. So you take a look at this full article here and get a better feel for it. But you get a little idea. There's the scene. Inside of it, there's game objects. On a game object, there are the components, and some of the components may reference assets, which is the cloud shown graphic there with material. We'll take a look at how we add a material into. This is really an action-packed video here. So let's jump back into the project. So first, I want to talk a little bit about some of the game loops that you have at your disposal, where you might put code that you want to repeat. So go ahead and double-click on the project itself. I'm sorry, the script itself. Open that up. So the first code that gets executed exactly one time when you press play, inside each of the components there's start, and inside here we have a few lines that are going to execute just one time. But let's see what they do. One of them is a coroutine. You can specify that, let's say, every 3 seconds you want code to run. Okay, so you're able to do something, a timer ticking down, you may want to have execute every 1 second. There's another way you can do that here by invoke repeating. You can tell the coroutine sample private routine to run. You can tell the method sample invoke method to run, and you can give them the amount of time you want them to run. Then there's another way to have code execute, and that's send message. So send message is not necessarily repeating code, but this is a message that's going to be broadcast to all of the scripts on this game object, and they can each listen back and hear when initialization happens. You could pass any method name you want there. The important thing is that this custom name on initialized matches down here a public method that I have called onInitialized. So let me go ahead and run the script again. I'm going to run it one time more. Okay, now pause. So let's take a look at what we've got here. I'm going to hit spacebar, and that's going to make the console window full screen. So first, the private routine runs, and with the note every 3 seconds. We see 3 seconds later it runs again. If we allowed the game to play longer, every 3 seconds we'd see the same output. So you can do enemy logic or other things that don't necessarily need to happen super frequently. You can space them out by seconds or minutes or however long you want. Then we have the onInitialize, which fires exactly one time. And then we've got the invoke method firing every 5 seconds. Now, most of the examples that you're going to see, and the way that a lot of people code by default, is that they'll put code inside what is called the update. So update is called every once per frame. So let's see, if I was to take this trace statement here and put it inside update, and I'll just show the word update, and then I'm going to give it a run. Inside the console window, you see we're up to 100, 200, 300 calls. I'm looking at the count here. There's 336 total output to the console, and most of those are this update. And that is called, in the case of a game that's running at 30 frames per second, that is called 30 times per second. So every time the screen is redrawn, this is executed. Okay, so that is one of our most frequent ways to put code. So if you want something truly to happen every frame, you put the code there. And that's how a lot of game developers work. I want to show these alternatives though. If you do want to optimize and you want to put some code in that will run less frequently, you can do it here. But a good first step for you may be just to use update, and then think as a last step where you might use the coroutines, the invoke repeating, send message. Send message is basically designed to run between two scripts. So here I have the script send message, and then I have it listen to it via onInitialized right here within the same class. But you could also communicate between two scripts this way. Let's see if there's something else I wanted to look at there. So I've taken out the debug inside the update. In fact, I'm going to comment out some of these other ones too. So let's do that. Uninitialized, debug. Yeah, let's look at how this coroutine works. So there's a special return type, IEnumerator, and by specifying that as your return, and then within what looks like the method here, we can do any code that we want, and then there's a special instruction that we can tell it to wait for 3 seconds. So what actually happens is line 103 executes, then after 3 seconds line 109 executes, which says go ahead and call me one more time. And then it comes in, it does the log statement, it hits line 106 again, waits for 3 seconds, and then it is calling itself again. So it is iteratively being called. You can also stop a running coroutine with some line there, 112. Okay, so let me go back to my previous plan of commenting some stuff out. Let me just go ahead and run. I want to see that no traces pop out. Okay, good. So let's talk about how this is set up. In Manager's GameObject, on the right, we see that transform in their inspector, and then we see the script. But how did we actually get that there? Well, what we'll do now is we'll create a new cube, put it into the scene, put some scripts onto it, get those scripts to communicate with each other, put a sound on the script, on the cube, and we will put a image mapped to the side of it. And I think that would be it. Maybe we'll be a little bit more talking as I go, but let's see. So we can do creation through the create menu within hierarchy. You get lots of options, but some of our basic shapes are here. You can also go to GameObject here, create an empty one if you want no visuals, but typically you want some visuals, so I'm going to use create other. And this is a similar menu to what we saw in hierarchy create. So let me go ahead and create a cube. It's going to put that cube right here. And as we saw in an earlier video, we can do translation, then we can go up and hit the rotation, we can hit the scaling, either doing it in one direction or by grabbing the center, all of them. And each of those changes in the inspector on the right, we saw those values changing. So I'm going to go ahead and put us back to the default. So now we're at the center of the scene, also called the origin, 0.000. And let's say by default, the components that we've got are a mesh filter, a box collider, and a mesh renderer. So the mesh filter itself is the geometry. The mesh renderer is what puts that geometry out into the visual world. And the box collider is something that is used for physics collisions. We won't do physics in this lesson, but that's what that's used for. It's used for knowing where its bounds are as if it was a real physical thing. It has both a look and a dimension that can be touched by other boxes, or the box could fall into surfaces and interact with physics. We also see that down here there's a material added, which is just a default material. It just looks like a white cube. So let's go ahead and give that a run. And we don't see much happening. Okay, but that's it. The rendered view is in the game, and the in editable is in the scene view. They look very similar right now. So let's add some scripts to that. So we'll grab our cube by just clicking it in the hierarchy, and then over on the right we'll do add component, or up here at the top we can do component add. And there's lots of scripts that are available here, including physics. But we're going to add a component, and I already know the name of what I want to add, which I would find by looking in the scripts here. Cube change color. So if I go to cube and add and start typing cube, it's going to show me all of the compatible scripts in my whole project, including the ones that we see inside the project window. So I would do cube change, no, I'm going to do cube rotate. So you can see it adds one line here for cube rotate. You can have that open or close. And we'll go ahead and give that a run. And now we see that we've got something happening there. Okay, so that code must be doing something rotating, and it's happening pretty smoothly. We'll see that that's happening in the update. All right. Now let's see if we were to add the change color. Now instead of clicking add component on the side, I can just drag this up right into the view here in the hierarchy and release on cube. I'm going to give this the name spinning cube just by changing it there. The order that you see in the hierarchy isn't hierarchical, it's just alphabetical. You can nest one object into another, but we don't need to do that for this lesson. So we're going to go ahead and press play. Now we see that the cube's red, and then as it spins, it turns green. And it spins some more, turns red. So it's going to toggle between those two colors. All right, so let's take a look at how all of that is happening. First, the rotate. So inside rotate component, we're extending mono behavior, as we always do. Then we've got a setter getter here. So from the outside of the class, we have a public property, current rotation we care about, which is my custom variable that just gives the X rotation value. In case somewhere outside of this component we want to be able to access that. You don't have to use a setter and getter, but that's my particular policy. So I use setter and getter so I could optionally control the access to that value. For instance, every time we set the value, maybe I want to say, if the value that's coming in is greater than 50, then I'll set it. But if it came in and it was 40, it would be ignored. So you're able to control the setting and the getting that way. And this is similar to other languages where you'd do a setter getter or accessor, as they might be called. Then down in the start, where we know code executes one time, we're going to do absolutely nothing. And then in the update, which happens every single frame, I'm going to access one of the built-in properties of transform, which is a shortcut to the transform component. And I'm going to call a method on that rotate. Now, how did we know that we could call rotate? Because if we go to the transform and we add the period there, it's going to show us all of the different properties and methods that we can access. Okay, there's lots of them, but one of them is to be able to do rotation. And I've chosen to go by moving a float of 0.8f. That's in the x direction, and we're not going to be moving in the next y or z. That's why we have 0 and 0 there. Then I'm going to store that value into our property of current rotation we care about. And I'll show you why we're doing that in a second. That's optional just to get the rotation happening. Only line 88 is needed to get the rotation. So let's jump over to the cube change color. So here we are in the project again. Double click on that. It opens up cube change color. So let's see. We're extending mono behavior. Then here showing how one component can access the value of another component. So this is a very typical paradigm where you break up what a game object does across several different components, and then you want those components to be able to talk to one another. So in this case, I'm going to inside cube change color component, I'm going to make a private variable of cube rotate component. Okay, and then inside the start, I'm going to set cube rotation component to get component, and this interesting looking signature here is what's called a generic. So what I'm doing there is I'm saying, can you get me any component on this current game object that's of type cube rotate component? And I know that there's one there. If there wasn't one there, it would return null. But I know there's one there because I've just dragged both of the scripts on, as we've seen. Then what I'll do is, oh, I don't want to do that just yet. So just looking at line 71, we get a reference. We only need to do that once on start, and we need to do it in start. We can't do it too much earlier in the life cycle because maybe hasn't been attached yet. But start is the perfect place to grab a permanent reference to another component. And then inside update, I will just call current rotation we care about, set that as a local variable, and then the colorization I was doing, I'm just checking that rotation. And I just did some trial and error here to see which angle would be nice to color it. So I just say if the angle is between 0 and 90, color it one way, otherwise color it another way. So let's go ahead and run that. Actually, I'm going to undo this here. So inside the color change, we'll see the debug log get fired. So let me go ahead and run. And inside the console window, we see that rotation float is being spit out. Right? So you can see it goes through about 360 degrees. And we're doing the color change at a couple key parts there. All right. So there we've seen adding components to a game object, having one game object, having one component color change the game object, having another component rotate the game object, having the color change component grab a reference to the rotate component and use a public method on it, or a public accessor value. So we're starting to see some of the ways that we can combine game objects and components. But what if you wanted this game object to get a reference to a the manager's game object here, let's say. So what I could do, I think I've made an error in this mistake, so let me here, game object find. Okay. I had experimented with a few different operations I wanted to do there, but now I think it's set up correctly. Let me just go ahead and run and see. Take away as manager. Oops, this is going to be a game object. Okay, and where's that update? Okay, I've undone that. So let me just run to make sure my syntaxes are correct here. Okay, good. So here we're getting a component on the same game object, storing a reference. And here I'm able to look through all game objects in the scene and get one by a specific name. So if you wanted to do have a component on one game object, speak to a component on a totally different game object, you'd go down this path here. And this would be a reference to the game object. Then you'd repeat something like get component, and then, you know, blah, the name of the component you want to get there. Okay. So just showing some of the ways that we're able to do component-component communication, and then come back. So let's look at the article again. So continuing component-component communication, we've got a reference to this source on some of these. So you can see that if we can do coupled communication, where we get component, that's what we do in this example. Coupled means that the two classes specifically are linked. One of them is using the name of the other one. And in some small projects, there's no problem with that. In a larger project, you may want to do what's called decoupling the communication, and you use send message for that. That way, any one class doesn't necessarily have a reference to another class. They're communicating a different way. So also make a note in that paragraph that advanced developers may want to create their own custom way to communicate between classes, and that's for a separate talk. Okay, so back here, when I had that debug traced out, we see it tracing right here. I'm getting an error because I'm not using that. So here it is properly tracing out, and that was the spinning cube having a script that reaches out and grabs the manager game object by using its game object name. Okay, and you'll see that technique used countless times through basic projects everywhere. All right, so let's take a look at just a couple more things that are pretty crucial to basic game development. We've got a red and a green color happening on the material there. But what if we wanted to put an image on? So this is an image taken from my website that I just dragged into the project just by having this window open, dragging from Finder directly into the project. And then all I need to do is just drag that right to the spinning cube object. And what that's going to do is it's going to automatically create a material for us, because it's not actually an image that gets mapped to a GameObjects mesh as a material. It needs to be a material itself. So when I go ahead and just drag this on there, there's no problems with it. It's going to automatically create a materials folder, and inside of that it's going to create a new material, and if we look at that material, it's going to be a reference to that image. You can give it a color which tints the image somewhat. You can decide if it needs to tile 2 by 2. You can now see that the image, let me zoom in a little bit, the image is actually being tiled on there, right? So back to just having it on there once. And let's go ahead and run just like that. We can see that our coloration is still happening, and it's happening on top of the material that's there. Cool. If you import models from Asset Store or from a 3D program that you want to use, they may already have the images mapped on. But for simple projects where you're just using these basic shapes and searching for a texture online and dragging it on, this is the basic workflow, and there's no problems with that. Now, what if we wanted to have a sound on there? Well, let's see. One of the built-in classes we can take advantage of by add component is audio source. So audio source, it wants us to drag in a reference to a clip. So this is something we haven't seen before, but in some of these components, there's properties that are exposed. By default, any public property that you create in any of your monobehavior subclasses, they're going to show up here. You don't have to show them, but that's going to be the default behavior. So typically what is exposed is things that we as developers might want to get at very easily. So one example is audio source. It's going to take a audio clip. So I've got an audio folder within our project, and I'm going to drag that right in. And then every time I play, we'll see that play on awake is checked. So when the object wakes up, which happens one time, just like start does, we're going to hear that sound. So it played a sound there. I'm not sure if that comes through on the video, but it's a simple chime. We're also programmatically now able to play that sound from within our components. I'm not going to do that in this course, but it's possible to do that in your project. That's how you would do it. You wouldn't necessarily just play on awake. You'd probably check that off, and then within your code you'd say, hey, go play that welcome sound, and play it each time a level begins or what have you. Let me see if that's all I wanted to cover. So we've taken a look at how game objects and components interrelate. We've seen how to communicate between a game object and another game object by using the find. We've seen how to communicate between a component and another component by using send message, and then I gave a better example with get component. And we had one component rotating, another component using the value of the rotation for a color change. We've seen adding a sound, and we've seen simply adding an image on, which creates a material. That's it. Thank you.